Okay, so good morning, everyone. I'm Chiara Gatto, PhD candidate from Politecnico di Milano. Today, along with my research team, I will present a large language model-based methodology for classifying and extracting cost data from tender documents. So, let's start with a brief of contextualization. Cost items are usually composed by an ID code and a textual description and a unit of measurement and a value. But the cost is not just a number. Instead, it is the cost depends from all the variables and information contained from the textual description. The problem is that there's lack in standardization in the way the information is conveyed to the users. So textual description can't be automatically understood by machine, but also the understanding process and interpretation process from practitioner can be subjected to semantic ambiguities, and therefore it's prone to error. So this study comes from a long path, a long journey, where in previous studies with my research team, we developed data structure for structuring information in the cost domain, and also an ontology, a cost domain ontology. So let's move on with the contextualization. Since we're speaking about text data, let's speak about natural language processing that in the last year, of course, proved to be helpful in processing textual data set in automatic way, but still needs the traditional approach, great manual effort in labeling the data set. The models are poor generalizable in fragmented dataset scenario, and the performance are strictly related to the quality of the trained dataset. So, on the other side, large language models are still underexplored in our domain, in the construction domain. And large language model promise to increase the performance while reducing the dependency of the from labeled data, but also the performance depends from can be affected by hallucination. So let's move to the research objective. We want to develop a methodology for automate the classification and information extraction from cost-related tender documents with large language model, with the aim to reduce manual effort in interpreting and encoding textual description, embed domain-specific knowledge into an adaptive and iterative pipeline, organize information according to this cost domain ontology, produce structured data in automatic way by classifying and by classification and information extraction tasks. So the methodology developed for this research is divided into 3 phases. The first one is knowledge documentation, where we start from the domain ontology previously defined. We need to extract, we need to understand the variables that could be useful for granting the model into this domain. And then we need to prepare those variables in a way that the prompt could acquire it. So basically, we produce a JSON file with structured knowledge documentation. In the second stage, we define a sequence of prompts, so by prompt chaining. We have 4 kinds of prompts. In the blue box, we have the prompts related to the classification, while in the last prompt, we have while in the last green box we have the prompt related for information extraction. So basically by prompt chaining, the result of the first prompt affect the composition of the second prompt, but also its output. And finally, the methodology foreseen a manual verification of the output and also an iterative refinement of knowledge documentation to improve the performance of these classification and information extraction techniques. Okay, so for this study, 70 sentences, 70 cost item description were analyzed. 10 description per object. So as you can see, each object has a different way for defining the cost description. So different lengths, different sentence data structure, different content. And now let's move on to the knowledge documentation. So let's start with the classification task. We need to prepare a JSON file for this specific task. So the classification is organized according to 3 hierarchical levels, where each object is defined by a discipline, a specific discipline, and a specific system. So for each object, we need to map each object according to this specific classification system. So for example, in this example, we show an installation panel and also a slab. We showed, for example, the discipline for this installation panel is architecture, but also we provide the definition of this discipline. Okay, so we did the same for the system, and actually for the object we didn't need to any further provide any definition. Concerning the information extraction task, we prepare another kind of JSON format with the few short example, a couple of examples of how we wanted to extract information in a structured way for each object. And now let's move on to a practical example. So we provide to this model with a definition. This is a flat reinforced concrete cost item description. The first prompt is able in retrieving which discipline this description belongs to. So in this case, it's structural engineering. And based on this information, the subsequent prompt is able in retrieving which system this object belongs, and so on, also with the identification of the object, and finally with the extraction of information. So once that we reach this level, we are able of extracting information and storing the information into a database. So finally, we can see that we perform 2 times this process all over these 70 definition. In the first case with a lower performance of the model, but in the second part with very good performance of the model, since we work on the knowledge documentation, we work on better describing what is the discipline, architecture, what is the system, and so on. So finally, with this study, we developed a methodology for increasing the performance of large language model in the classification and information task. So we automated the process of assigning a cost domain description to cost items, significantly reducing this, the time needed for doing this task. This methodology can support practitioners in the domain knowledge definition. But as cons, we have that structuring knowledge is an important phase where still, of course, human effort needs to be placed. And this study was performed on a very, let's say, small sample, so we need to increase for future developments. But also for future developments, we should consider to embed this model into a larger pipeline for performing other kind of activities, such as consistency check across tendering documents and also cost estimations. This is a list of references, and thank you for your attention.